All right, we're about ready to move on to our next topic. On mass timber as an advanced building material, a solution to industrialized supply chains, brought to us by Arizu Sadoki. Are you turn on your video and start sharing your screen? Oh, there she is. And do we have also Justice Waukee? Okay, there he is. All right, let me introduce these folks. Arizu is an assistant professor at the Sustainable Technology and Built Environment at Appalachian State University. She's also the co-founder of Mass TI Mod, which focuses on improving volumetric modular construction by enhancing productivity, sustainability, and product quality. She has worked in the design and construction industry, providing solutions to construction problems, particularly off-site construction. She received her PhD in construction management at the University of Florida. Justice is a graduate student at Appalachian State University pursuing a master's degree in sustainable building design and construction. His research interests include life cycle assessment, automation, and use of mixed reality technologies in the construction process. So we'll turn it over to you and let you take it from here.
Thank you
Hello,
so much.
everyone. I'm Justice Oshike. I'm a graduate student at Appalachian State University, and I'll be presenting a collaborative project between Appalachian State University and Stanford University, which explores how mass timber and the concept of industrialized supply chains can transform how we build and manage housing supply in the US, especially in high-need regions like in the California. So on our agenda today, we'll begin with the team behind the project, then we'll dive into key challenges we identified and the goals of our research, how the US or how the ISC model functions, and then how the broader implications for the construction and forest management. On the team, I've had the pleasure of working alongside Dr. Arezu Sadugi. She's the founder of Mastimod and a pioneer of sustainable design. She's also an award-winning architect. I've also had the pleasure of working with Dr. Martin Fisher from Stanford University. He is known for his groundbreaking work in virtual design construction, and his research aims at improving the productivity of project teams involved in designing, building, and operating facilities, and to enhance the sustainability of the built environment. And myself, I'm a graduate student, and my research is focused on life cycle analysis, emerging construction technologies, and visualization tools that aid in design and delivering construction.
Hey, Justice, real quick, it was my bad. I didn't know Martin was going to be joining us for this. I know he had a conflict this morning, so you just introduced him. Thank you for that. And Martin, welcome to the conference.
Yeah, so on to our problem statement. We began by identifying 5 major challenges facing the construction sector, and many of which are deeply interconnected. We have labor shortages and fragmented supply chains. We have tariffs that increase costs of imported materials. We have a severe housing shortage, especially in states like California. We have a forest biomass buildup, which acts as a fuel to wildfires. And we also have a lack of systems connecting forestry outputs to housing inputs. Together, these call for a thinking of how we structure supply chains in the built environment. So, our goals and objectives for this research. Our response to the problems identified was to propose an industrialized supply chain powered by mass timber. And our objectives are to propose a supply chain that's industrialized, localized, and resilient. We also aim to foster regional jobs and strengthen local economies. We aim to reduce embodied carbon and waste and also increase the housing production efficiency. So looking at this graphic, we can see that there's a huge imbalance in demand supply of housing, and this is most severe for low-income families caused by inefficient and slow-paced house building and production. This brings us to the housing shortage in California, where only 24 units exist per 100 households at the lowest income brackets. And this is due in part to our resilience or reliance on slow, inefficient construction methods and imported materials, which are hugely affected by tariffs. There is also an untapped potential in our forests that, if linked, could help in the housing sector. So how does mass timber bring value to forestry? The US having over 800 million acres of forestry. There is 58% which is private owned, 31% federally owned, and 11% being state and locally owned. This is a huge resource that if tapped and harvested could help use in the production of the ISC model. Mass timber offers a way more purpose to underutilized materials such as pest-killed materials or pest-killed trees, and the USDA supports this direction, noting that it not only promotes forests, but also helps in adding economic value to forest cleanup efforts. So next we look into federal ownership of forest land. Ownership matters because access and policies vary, and the US has over 30% of the US forests being federally owned, but in California, this number jumps into up to 57%, which is a huge resource that with systems in place, we are missing the opportunity to harvest and process these forests in such states. So let's look at the benefits of mass timber. And here is a quick comparison of using mass timber versus conventional framing of horizontal elements in a building. Mass timber helps by eliminating joist hangers, thus reducing material and labor costs. They also offer a wider unobstructed floor space for MEP systems. Mass timber is comparable in weight while offering better structural performance and fire resilience compared to the traditional joist systems, and it also enables faster and safer construction with less waste. Now looking at the ISC model, I will hand it over to Dr. Rezu, who will be discussing our industrialized supply chain model.
Thank you very much, Justice. So what is the ISC model? What we're proposing as a solution to the problems that Justice mentioned. So it's a circular, resilient, and digitized system. In this graph, you can see the way that we compare current state of timber supply chain with what we're proposing is the ISC model. So the key factors for timber industry, of course, connects I would say the supply chain of timber with forestry and forest service officials that work for governments at the state level and the federal level. So I would say the government can play a big role here, especially where in California, Justice mentioned, more than 57% of the forest lands owned by government. So what are these factors? Forestry people calls underutilized wood as a biomass crisis, but they don't have a systematic way to understand what the sources are and how they can manage it. On the other hand, we're talking about housing. Most of the housings are handled project-based. That means that there's no systematic way to look at them as a production system. Also, it comes with high cost and high environmental impact, and of course, some, I would say, short-term solutions comes with dependency on tariff and imports from outside of the country. So what we're proposing here is the way that we can help forest restoration, sustainable forestry, localizing resource management from using federally owned forest lands and helping whoever wants to invest in this industry as a mill work, as mill owner, or how we can manage the resources that we have and connect them with the demand in housing. So we can call that the primary goal of this model is to link timber industry with housing industry in an integrated way. And of course, it comes with components such as circular economy and workforce development improvement. Next, please. And the way that we approach this is to introduce mass timber as a key building material that itself can function as the structural system and at the same time comes with architectural features. And in that regard, mass timber itself, with its property, it matches with many of the factors that we studied as industrialized supply chain requirement. For instance, mass timber requires digitalization. There's no way, or it's very difficult and most, I would say, very expensive to cut and produce, I would say, fabricate the mass timber panels at the job site. So it has to be computer-controlled machine used to produce mass timber outside of the job site in a controlled environment. And itself, it requires building information modeling. It requires to have a data flow to understand what are the capacities of the building as a project and what is the capacity of the production in the factory. And on the other hand, if you look at the forestry, mass timber allows to use more underutilized low-grade timber, which it creates more demand for the supply, extensive amount of timber that often goes to landfill because there's no demand for it and they don't know how to use them outside of the forest land. And itself, it also, like I said, it comes with digitalization, and that remind us of the principle of industrialized construction. So again, addressing the industrial supply chain, it both address what happens behind the scene, which is behind the scene of building construction, which we call supply chain model, and at the same time, it look into the end-to-end supply chain, means that it goes through the lifespan and life cycle of the building. Next, please. So the key component of this system model that we're proposing is to integrate and connect the stakeholders. And the first step to that is to identify who are the stakeholders. Majority of the, I would say, housing construction projects that don't deal with the stakeholders in the timber supply chain. So they don't know the way that the timber managed from the forest land and it goes to the millworking and it produces lumber. They go to the lumber distributor or even material distributor, and that's where they start their job with a building construction project. So forest managers is becoming more important in this model, and understanding what are the capacity of our forest land. What is the data inventory? How do we know how much resources do we have at the state level or the country level? And looking at this system allows us to have a digital platform to let people to understand what's going on at the resource level and what's the demand on the housing production level. And it's also important to note that it's extremely expensive to bring all of the stakeholders in one place to be able to help them to coordinate and communicate. So a digital platform is becoming more critical here. And it allows to connect these people as individuals, and also it allows to have a better data flow and data management. Next, please. And circularity by itself, if it did run and optimize the system very well, it comes as a key component. If we plan from the beginning that we're looking at the building lifespan, the early stage of the model, start from the resource planning, it goes to the design and manufacturing and delivery. It itself operates well and allow us to handle and connect the resource management with the supply chain management. And again, addressing mass timber is a key material here because it supports efficiency and prefabrication, and the I would say key factors such as waste reduction, it itself happens with using more advanced timber products such as mass timber. Next, please. All right, and another key component is workforce development. In California, there's a few in progress manufacturing facility for mass timber happening right now. So most of the projects had to feed what they need, the material supply from outside. So it's often that they come with the cost of transportation from thousands of miles, even from Canada or Europe, to address the needs of the fast-growing mass timber building industry in California. And that's the same scenario elsewhere, because the number of mass timber production in the country compared to the growing demand in building sector, is not enough. And of course, if we look at this model systematically, it definitely comes with better forest management, new jobs on the forestry side, the people that would need to manage the forest inventory at the same time, the way that they do produce lumbers, and in other hand, the manufacturing of mass timber, and of course, understanding the need and capacity of housing production. Next, please. All right, so what we are looking at here as a summary of the outcome that we are looking into. So with this model, we are thinking of, like I said, the main goal is to connect timber industry with housing. So we definitely looking at to leverage sustainability here under the forest management at the same time for housing. So if the system runs well, the impact is that of course comes with better quality housing. And this is not the end of the story. We want to make sure that what we are investing as a researcher, our time and providing a solution, it also allows other regions to use it. So it has to be scalable. But being scalable means that it doesn't mean that we are sacrificing localization. We are creating as a roadmap that can be scalable to other regions that want to use the same method. Next, please. So what is future steps? Here, I would like to invite industries and potential collaborators, developers that let us to start with a housing project and understand well what are to identify the data that we need to provide and study for make this model feasible. And with that regard, I would say government engagement is also important, because if we are looking at that number that I mentioned, 57% of California forests, this is a huge number. And I know that recently the Forest Service has a new policy to help to feed the more, I would say, timber supply to the industry. And that's something that I know that they have started. And I think future collaboration and future communication would comes with a win-win, I would say, status for us and for them to create a production system that helps both industry at the same time. And also, I would say CAL FIRE would be helpful to be involved, because especially post Southern California, LA fire, they're looking at more advanced timber product, or there's a mindset that timber is not fireproof. Of course, it's not fireproof, but it comes with better fire resistancy compared to lightwood framing structure. That definitely something that interests CAL FIRE and other agencies related to fire management. Next, please. So what we are concluding here, the system that we are proposing, it's focusing on a building material supply chain, which we call it mass timber. And we talked about the reasons that we proposing mass timber as a key component of the system, as why it becomes a solution. And the triple win, it's something that not only addresses housing, also climate and environmental impact, but at the same time, local economy improvement. And the tools that we're going to address, it engage the digital tools, and of course, the fact that we need to start with data collection and understanding well the capacities, because the more time and investment we put on the planning phase and on the understanding the system, it helps us to have a better and optimized, I would say, results at the end. Next, please. Okay. Well, thank you so much. And we come to the time that you helps us with your questions, better keep this move forward to address the housing crisis in the country.
All right, so have you actually vetted this with folks in the government to see if they're interested in supporting? Kind of where are you?
In forestry, yes. In forestry, yes, they are supporting, and especially there is a, of course we can't talk about tariff. There is a new, I would say, policy that helps or at least facilitate a movement like this to engage more domestic production.
All right. So it seems to me that the mass timber manufacturers would be very interested in this because that's the product that they're advocating, and that it's going to have to compete relative to traditional methods. I'm just curious how you drew the boundary, picking up Mark's presentation, how you drew the boundary, where you drew that. I'm curious about that.
When you say boundary, you mean exactly framework of the project?
Yeah, so you could have circled the boundary around the production of mass timber and let then the marketplace decide where it goes and what it does and how it competes. But you could have circled the production of the product back to the origin and the raw materials for the product, and that's the production system. But you went all the way to the end use, if you will. I'm just curious how you decided where to draw that boundary.
In reality, I would say if you want to make it in real world scale project, because of it's going to be really costly to start with thinking of a new facility, new mass timber facility for the case study. The way that we looked into is that we start with a project working with a developer, like a housing project.
Mhm.
It's probably is not going to be exactly the same as what we are, because so this is how the industry has already done this before and failed. Raising money to start with a manufacturer without having enough good, I would say, plan how to feed this manufacturing facility. It's one of the reasons that they failed. So focusing on the facility or like I would say the manufacturing itself, I don't think is the best approach. The best approach is to first start with a case study, a project. We mentioned that it doesn't have to be like that. Being a project base is another problem, but just as a case study to understand and to be able to study the data stream, right? So if you have a project and a developer and a team that, or their goal is to use mass timber and they value these at their own, like whatever their business model works, and then we can help them to understand that, okay, so on the forestry side, what the inventory and when the resource management look like, and when we help them to understand, okay, what is the quantity that they need per their projects, and then how we can provide that quantity using this model from the resources that probably they haven't thought through or they didn't really worry about it. And because most of the developers and builders, like I said, they don't even bother themselves looking into the supply chain, because that's how it works. They go to distributor. But if we have the system behind the distribution, something that occurs before the lumber is ready for them to use, that's something that we can help, and then we would sort of incentivize them to use this model rather than going to the distributor. This is a simple example. In the meantime, of course, we do need to have a CLT or a mass timber manufacturer engaged. But this is like I said, this is as a proposed level stage, and the primary goal for us is to understand how we can make the list linkage, and if we be able to make it successfully work, then we can bring it to the government. Hey, let's say this is how it works, and we want you to support starting, and or let's say, so if there are proposals to the government table that we want to bring jobs, making a new mass timber facility, they would understand that helping whoever those folks that wanted to start a new facility connects with this system and help them to track the flow of data to the I would say California forestry, at the same time to the building professionals. So this is the way that I look at it. Dr. Martin, if you're talking, you're on mute. Okay.
And Martin has a question for the audience. This is a first. He says, does anybody have experience in using production process modeling and optimization to connect, align, integrate different production systems, like here in the lumber production and forest and housing production and other industry sectors? Great question. So we'll turn it loose with the audience, or maybe our other speakers. Or maybe we'll just have to follow up with Martin.
Yeah. I mean, for me, this has been, if I step back a bit, right, of course, I think the collaboration here that I've enjoyed with Arezzo and Justus is addressing real problem and opportunity. And one thing that so kind of started out in part by saying, well, we need to understand, and first of all, we need to understand how the different production systems actually work. And then we need to see where the misalignments are, and see what could create alignment, right? So that we can really scale up the integrated combined production system, not just production of lumber in the forest or housing, mass timber production capacities, and so on.
It'd be interesting to map and model the production system that was proposed here.
Yeah, and so that has been one of the kind of takeaways for me, just broadly speaking, the value, right, of these methods to actually really understand a bigger system, because at the end, the bigger system also needs to produce something.
Yeah.
And to get out of the more myopic view of producing, something in a particular. So each of the individual production systems has to work, but then also has to work together. So I'm just curious whether others have had experience in trying to create this kind of understanding and alignment in other sectors. Yeah.
Gary, it's Todd. Can I add something?
Yes, please.
Yes, I think what if Enzo's still on the line, he'd be excited because now we're moving up to the system level. But I think the system level for this is what we would term value chain modeling, and thinking about the value chain from demand through the supply and how all that occurs, and how you go about identifying and defining that value chain. But it's definitely a production system, or a value chain as a production system, I think, is what's on the table here. And there's a few of those applications going on right now. I'll give you one of them's in the data center space. How do you create the optimal liquid to liquid cooling value chain, right? And so there's multiple players and multiple things going on within that value chain, all serving multiple customers, and the customers having varying demand, if you will. So I think this is a great problem that Martin's proposing here.
Agreed. All right. Well, very good. Thank you for submitting the paper and taking the time to share your thoughts with us.